Hi everyone, for today's math journal we are doing lesson 3.8, so make sure to get the lesson title on here with the date in a box and the lesson number 3.8. You will need these colors out. You'll need red, violet, blue, green, yellow, and orange, and then set up your journal to look like this. Today we're going to be talking about practicing or reviewing how to add, how to subtract, how to multiply, and how to compare fractions. So go ahead and push pause on the video until your journal looks like this. Once your journal looks like this, we're going to move on. The thing that we want to draw is going to be a chart, and we're going to be doing all of these operations in the chart. So we're going to start about right here, and we're going to go down maybe until you get like halfway or to the bottom of the hole on the left right here. And then I'm going to go over, just making this more of a rectangle. So I've made one of those. We're going to also draw another one right below it. So we'll shift that and maybe skip about 3 or 4 lines and then draw another one. Going all the way down, the same distance across. I think I'll stop right there. So that you've got 2 open boxes. We're going to turn them into charts. What we're going to do on this is split the side. So it looks like that. And then we're going to come across the top like that. And we're going to be doing all 4 of these things in here. So you need 4 sections, not including this title part. So you're just going to go in half and in half and in half the best you can. So I split that one in half. I'm going to erase that. Okay. Let's split this one in half. And then we'll split that one in half. So it's not perfectly cut across. You can tell this one has 2 lines and these have 3. It's not a big deal. The first thing we're going to do is actually the comparison. So we're going to color this whole first, actually looks like the second row. We're going to make that all orange. And we're going to be doing comparison. So you can put this is what they do for a comparison symbol. They just let you know that that's what you're going to be doing there. So the fractions that we're going to be working with to do all of these operations is 2/5 and 7/10. So we're just going to do this above on the title. 2/5 and 7/10. Now we're going to compare those two, 2/5 and 7/10, and then we'll move on from there. So to compare them, you just put them in this order and you use a comparison bubble. So it looks like this. If I am comparing 2/5 and 7/10, I would write it like that. 2/5 and 7/10. It can also be written the reverse way where you put, so we're going to write or, you can put the 7/10 first. Doesn't matter. You're just comparing those two, so you should get used to doing both. So 2/5 and 7/10. So when you compare these, this one is pretty obvious because we know some things about mental math. We know how to compare these to a half. Half of 5 would be 2.5, and I only have 2. So this one is less than a half. So I'm just going to put a little arrow down. That one was less than a half. Half of 10 would be 5, and I have 7. So this one is more than a half. So you should already know that the bigger number is 7/10, the bigger fraction, and it looks like 2/5 is less than 7/10. Or if you reversed it and wrote the 7/10 first, then you would say 7/10 is greater than 2/5. So this comparison bubble, we're just going to make these orange. Remember Pac-Man? So that is what comparing fractions looks like. We've done this for a long time now, so you should be fine on those. The next thing we're going to do is add, then we'll subtract, then we'll multiply. So we're going to do add, subtract, and multiply. So add, we're going to make this row be this color. The subtraction row will be this color. And the multiplication row, or the multiply, will be yellow. Okay, so let's come back up here to adding. So this looks like this. 2/5 plus 7/10. We're using the same fractions for all of these operations. Now, you know something about adding fractions. If they do not have the same denominator, you have to make them have the same denominator. That is a rule. So, there's no way I can fit all my work in here, which is why I have plenty of space off to the side. So our first rule with adding and subtracting fractions is stack them up. So I'm going to stack up 2/5 and 7/10. Remember, no number should touch. Make that equals bar really long because they don't have the same denominator. And you look at the tenths and the fifths, and you have to find the least common multiple between those two. So, if I list multiples of 10, you tell me when to stop. Ready? 10. Stop. 5 can change into a 10. So that's awesome because I get to leave this 10 alone. So I come back up here and I use my robot voice. Find this equivalent fraction. How did I get from 5 to 10? I times by 2. And 2 times 2 is 4. Wiki wiki, remember? So now I have 4/10 plus 7/10. The denominator is stubborn and stays. 4 plus 7 is 11. And now I have to fix this fraction. How many times will 10 go into 11? It'll go in once. And that's like taking away 10/10. So you have 1 and 1/10 is your final answer for the addition. So I'm just going to come over here and bring it into my box to say that equals 1 and 1/10. But you really need to make sure that you showed your work off to the side because that is not mental math. Even though some of you might be able to do it in your head, I still want you to show it. Okay, now we're going to subtract. Now this is pretty great. When you do the subtraction and you're dealing with these two numbers, they just want to know what is the difference. What is the difference between those two numbers? So it doesn't mean I go 2/5 minus 7/10. The difference between these two numbers is that I have to use subtraction. And I have to put, with subtraction, the biggest number first, the largest number on top. Let's make sure we write that right here. Largest one on top. That's going to be really important. Let's just show all of our work over here because they do not have the same denominator, right? Fifths and tenths. However, I've already done the work for making them be the same denominator. So technically, I could just write 7/10 because that's the larger number, minus, and I would have to say 2/5 because that's the original number, but what does 2/5 convert to? 4/10. So why don't we just write 7/10 minus 4/10 to find out what the difference is. And the denominator would be stubborn and stay. And 7 minus 4 is 3. So my final answer for subtraction is 3/10. Hopefully this is making sense. All right, the last operation we get to do, which is so great, and it's so much faster than adding and subtracting, is multiplication. When you do multiplication, it does not matter which one comes first. So we're multiplying 2/5 times 7/10. And you could represent that multiplication with a dot if you would like to instead of a X, but that's fine. Okay, remember the rules with multiplying. This is a fraction of a fraction. So a piece of a piece. So piece of a piece. I'm writing that really small in there. This is a piece of a piece. So the fraction I get at the end for my answer should be pretty small. So who remembers what the rules are for multiplying a fraction by a fraction? You extend the bar. So I'm going to use yellow. You look for relationships between the top numbers and the bottom numbers. So 2 and 5 do not have a relationship. 2 and 10 do have a relationship. They can both be divided by 2. So when 2 gets divided by 2, it changes to 1. When 10 gets divided by 2, it changes to 5. So now my fractions look like 1/5 times 7/5. That's what it looks like. So does 7 have a relationship with this number? No. Does 7 have a relationship with this other bottom number? No. So now I can multiply straight across. 1 times 7 is 7. And 5 times 5 is 25. 7/25 is a pretty small fraction. It's not even half. So that makes sense because I took a piece of a piece. And the answer cannot be simplified. They don't share any common factors. So my final answer for that is 7/25. So this whole review practice is just doing all of the operations we know how to do with fractions, quickly practicing them. So let's try to do one more set of these down below. We're going to go in the same order. So go ahead and set up your chart the exact same way. The two fractions this time are 3/5 and 4/7. 3/5 and 4/7. Three-fifths and 4/7. We need a total of 4 boxes here. So I'm going to end up drawing right in the middle of those to make them even. And we're going to use those right colors. Same colors we used before. We're going to go in the exact same order. So we're going to compare. We're going to add. We're going to subtract. And then we're going to multiply. Let's start with multiplication this time. Let's work backwards. It'll be pretty fun. Okay. Here we go. When we multiply, it does not matter which number comes first. 3/5 times 4/7. All you do here is extend the bar. Look for relationships. So 3 does not have a relationship with 5. Does 3 have a relationship with 7? No. 4 doesn't with 7, and 4 doesn't with 5 either. So we are ready to multiply straight across. 3 times 4 is 12, and 5 times 7 is 35. I know that it's already simplified because I couldn't do any simplifying over here. And 12 and 35 don't share any common factors. Pretty cool. Okay, now let's do subtraction since we're working backwards, and subtraction is this color, the aqua blue color. We're working on this section right there. We're doing subtraction. When we subtract numbers, you have to know which one is bigger. So technically, this one is kind of hard to do next. I think it might be better for us to do comparing first, then we could jump to one of these. Because this way, we already have this done. You can't subtract if you don't know which number is bigger. So let's compare them. Remember to compare them. We just put them both down here. And you write it both ways. Compare it like that. So there's a couple different things you can do. You could cross multiply because both of these are a little more than half. I would do that. I would cross multiply, or I would change the denominators to be the same. In this case, I think I will cross multiply. So 7 times 3 would be 21, and 5 times 4 would be 20. So the 21, 3/5 is just a little bit bigger. And then over here, if I reverse it, the 4/7 was bigger. No, sorry. The 4/7 is smaller. Whew. Good catch, Miss Fisher. And so it would be like this. So it reads 3/5 is greater than 4/7, or you can say 4/7 is less than 3/5. So now I know which one's bigger. 3/5 is bigger. So when I come to do subtraction, I'm just going to write it like that. 3/5 minus 4/7. You cannot do this. They don't have the same denominator yet. So you stack them up over here. 3/5 minus 4/7. And it has to have a long equals bar because they don't have the same denominator. So you think to yourself, okay, remember I'm doing subtraction. I have to have a 7 and a 5 change into something. They have to share a multiple. So I just start with the higher number, which is 7. And I list multiples of 7 until I find one that works. Ready? Tell me when to stop. 7, 14, 21, 28, 35. Stop. Because 5 can also change in to 35. So now you find these equivalent fractions by using your robot voice. How did I get from 7 to 35? I times by 5. And 4 times 5 is 20. Wiki wiki. How did I get from 5 to 35? I times by 7. And 3 times 7 is 21. Wiki wiki. 21 35ths minus 20 35ths is only 1 35th. It is tiny. 1 35th. So I'm just going to put my answer here because I showed all of my work over to the side. So the answer for the subtraction problem is 1 35th. Now when I go to do the addition problem, I already know that we're going to change them to be 35ths. So when I do this addition problem, I just go, well, I'm going to say 3/5 is 21 35ths. So 21 35ths plus 20 35ths, this time we're adding them. That's going to be a big number here. Well, the denominator will be stubborn and stay. That's pretty lucky. But 21 plus 20 is 41. So then you have to fix this because it's a fraction that's greater than 1 whole. So how many times will 35 go into 41? 1 time. And what is 1 whole when you're dealing with 35ths? It's 35 35ths. So you just take away 35. I can't do that in my head, so I really do use my fingers or something different to think that through. 41 minus 35 should be 6. So I have 6 left, and 35 is my denominator. Do 6 and 35 share any common factors? Remember, the factor of 6 is just 6, 3, 2, and 1. And the answer to that would be no. They don't share any common factors. So there's my final answer for the addition. 1 and 6 35ths. I forgot to color the comparison row orange. Will you please do that? So this was just a quick review for how we deal with all of these operations with fractions that we've learned. At the bottom of our journal, we're going to write a little phrase that'll have us turn our journal page to the next page, and then you can see what to do in the next video. So at the bottom, we're going to write, now, time for the real world. That means story problems. So we just did all of this practice when it comes to just the operations. But I want to make sure that as a 5th grader, you know how to take all of these operations and use them in real world situations. That's a story problem. So it's now time for the real world. I'm just going to do my arrow in that color, and maybe I'll underline all of it in orange. Maybe I'll give my exclamation point in yellow. And the only thing I don't have here is a blue, so I'll make that a star. So it says, now, time for the real world. And in the next video, you can see what we're going to do on the next page.